So we were talking phase shifts, and let's do some examples of those. So suppose I have y equals cosine of x minus 3 and I want to find a phase shift. Well, here b equals 1 again and c equals 3. Notice that in the general form the reference is always a minus here. So c is still considered to equal positive 3, and this means that this function is going to shift right horizontally 3, or a phase shift to 3. Okay, suppose we have y equals sine of 3x minus 6. So in this situation, we're going to have a change. We're going to have a b here, and this is going to, of course, change our amplitude, but it also affects our phase shift. And here we have b equals 3, c equals 6. So c over b equals 6 over 3 for a phase shift of 2. So we're going to shift right again 2. Okay, let's do one more. If y equals sine of x plus 2, we're going to have a b equals 1 and a c equals 2. So c over b equals 2 over 1. Actually, this is minus 2, because notice this is plus now. So this has to be minus in order for us to have the general form of x minus c. So we have a phase shift of essentially 2 left. Shifts our function 2 left. Okay, so as you might have guessed, all these ideas can be going on at the same time. So we might have y equals the sine of 2x. And I'm going to change this to make it 1/2 cosine of x over 3 minus pi over 3 plus 2. So we've got everything going on here. So let's start analyzing this thing. So the amplitude equals, well, that's simple. You just look and see what this is multiplied by. So the amplitude equals 1/2. Our vertical shift equals 2, and it's positive, so essentially it's going to push the whole function up 2. And now we get to our phase angle. So, well, first off, let's do our period. Remember, our period equals 2 pi divided by b. And our phase angle equals c over b. So in this relationship up here, we have b equals 1/3. That's the coefficient in front of x. And so I'll need to rewrite this equation so I can figure out what my phase angle is. Y equals 1/2 cosine, let's use square brackets here, of 1/3. I'm going to pull 1/3 out of this relationship. And now we have the x minus. So anytime you got x minus, you know that this number right here is going to be your phase angle. This is pi over 3 divided by 1 over 3. Notice if I multiply 1 over 3 back in, I get the original equation, plus 2. So we can see that c is pi over 3 and b is 1 over 3. So those 1 over 3's cancel, and you end up with pi over 1, or pi. So our phase angle is pi, and here we have our period is 2 pi divided by b is 1 over 3. So I can multiply this essentially by 3 over 3, which is the same thing as multiplying by 1. This cancels with that. So this equals 6 pi. So 6 pi is our period. So our period equals 6 pi, and our phase angle equals pi. I went ahead and plotted this with MathWay to check my result, and I can see my maximum value here is up here, and that occurs at pi. So the sine value, the cosine function usually starts at 0 at 1, but that's the maximum value. So this thing has shifted pi over, and every value in this function has shifted pi over. Now, this is our phase angle. Okay, now the next thing I notice, this is 3, this is 1, 1, 2, 3. So this thing is going, so this is the maximum that goes up, and the minimum is here. So each of these ticks is half. So a full tick is 1, which means half of that is our amplitude. So this is a half. That equals our amplitude. This equals our phase angle. That's our amplitude. Okay, next, I see if I mark this here, and I mark this here, that the distance between here and here is half of pi, and the distance between here and here is half pi. This is minus half pi. I can see that my function goes half a cycle in this distance. And this distance overall, this total distance here, is 3 pi. So to go a full cycle, I have to double that. I have to go 6 pi, and that's our period. Now, our vertical shift is a little trickier to figure out here, but because we have the amplitude's been changed. So if this was a typical cosine function, our amplitude would normally be 1, and it would oscillate between minus 1 and 1. But since we're halved, we oscillate between minus a half and a half. So we oscillate between these 2 points. So this, if we didn't have any other shifts going on, this would be how high our function oscillated. But since we have a vertical shift of plus 2, this goes up 1 and 2. So this is our vertical shift. So yeah, everything matches. Now we could reverse the process. Given our plot, we should be able to figure out what the equation looks like. So let's do that now. Given a plot, let's write a sinusoidal function that represents this. So this could be either a sine or a cosine function. Actually, we could write both. They would vary slightly because the sine and the cosine are just a phase shift off of each other. But let us see where to start. Well, I think one of the easiest ways to start is the amplitude. That helps us. And so how high is this? We go up to 1 and down to minus 5. So 6 over 2 is the amplitude. So we have an amplitude of 3. Okay, so now we want to make this fit one of these 2 functions over here. So I'm thinking the next thing is d. Let's figure out what d is. So to do that, I'm going to find the midpoint here where this thing oscillates around. 1, 2, 3. so it's half the amplitude. So this thing is oscillating about -2. So essentially this has been moved either up or down depending on whether I'm going sine or cosine function. So at this point it might be a good idea to nail down our main function. And I'm thinking, because this is really close and it's an integer away from where the cosine, this looks like I could start my function here and it would go like this, come back around and go here. That's a full cycle. So if I start my function here, it looks like I was shifted from the y-axis by 1 if I use cosine. Now if I use sine, that's a little more tricky to figure out the shift. I guess maybe here we could go here, but let's just stick with cosine. So it looks to me like our vertical shift then is 1. To bring this line back up to x is 2, 1, 2. So we went down -2. So that's our vertical shift. Okay, now let's figure out our period next, because we know that P equals 2 pi over B. If we can figure out what our period is, we can calculate what B is. So again, I said our period goes from here to here, and these are actual numbers, so we go 1, 2, 3, 4, 5, 6. It looks like 6. So our period equals 6. That means this equals 6. So B equals 2 pi over 6, or pi over 3. Okay, we're almost done. All we need is C. So we figured out what C is already when we set our function up to be a cosine function. And that means not C, but our phase shift is 1. So 0.4, our phase shift, we've decided it's going to be equal to 1 here in this function. So I need to kind of rewrite my function here so I can figure this out. So f of x equals a cosine of, let me use the hard brackets here. Okay, I'm going to pull the b out, x plus c over b. And this means that c over b equals -1.